Let's see what is the next one trying to say. Suppose two circles are touching at A. It seems that they are touching externally, so you can say the two circles touch each other externally at point A. Through A, two lines are drawn intersecting one circle in P, Q. Two lines are drawn through A intersecting one circle in P, Q. Another circle X, Y. Prove that PQ parallel to XY. PQ parallel to XY. Now children, I just want you to pay attention to this. Whenever you are supposed to prove something parallel to something, you should always keep three things in your mind. In your class 10th, it is basic proportionality theorem. Converse of basic proportionality theorem, I'm sorry. Converse of basic proportionality theorem, which will help you out to prove something parallel to something. In your lower classes, you have studied something called as converse of midpoint theorem. Midpoint theorem. In your lower classes, you will have studied midpoint theorem. Class 10th, you will have studied converse of BPT, right? And the third is what you have been studying from past 2-3 years. Tests for parallel lines, corresponding, alternate, interior. These are the three things which will help you out to prove anything parallel to anything. Mind you, just keep this in mind. Whenever you are supposed to prove something parallel to something, keep all the three over here. Whichever is applicable, apply it. I doubt midpoint theorem is getting applicable. We don't have any midpoints. I doubt converse of BPT is getting applied. So who is left now? The test for parallel lines. How many tests for parallel lines we have? 3. Alternate, corresponding, interior. Now, with this kind of figure, is interior seems possible? Because for interior, we need to have something, two lines coming in front of each other. The angle should be supplementary. With no angles given to us, interior is gone. Next, corresponding. Again, with lines crisscross, is corresponding possible? No. So who is left now? Alternate. Alternate angles. I just have to keep that in my mind. There is a very important construction. If you do that construction, then and only you can get this particular solution. Otherwise, it's difficult to get it. So please don't forget this construction. What is a construction? Construction is draw a common tangent to both the circles passing through A. Draw a common tangent to both the circles passing through A. So let's go for drawing a common tangent which is passing through A. I know it has not become that accurate, but please understand this is a common tangent which is passing through A, which is common tangent to both the circles. Let me say draw common tangent, say Mn, say Mn. So what is our construction? Draw common tangent Mn. Pass a common tangent Mn to both the circles, I've written shortcut, passing through A, passing through point A. Children, what I would like to do is, I would like to make you understand first the skeletal solution, as I have done many a times earlier. I have told you what skeletal solution is, right? Those who are watching all my videos in my Refresh Concept app, they will know what skeletal solution is. So let's start with skeletal solution. What type of angle? Angle PAM and angle PQAR. I repeat, what type of angle PAM and PQAR? Are they tangent secant angles? So can I say angle 1 congruent to angle 2, tangent secant theorem? Can I say they are tangent secant theorem? So my skeletal solution is here. Within this, we are done with our sum. If you think that, sir, our solution is that small, indeed, our solution is that small. So angle 1 congruent to angle 2 by tangent secant theorem. Whatever I did for larger circle, can I apply the same thing for smaller circle? What type of angle NAY and AXY? Again, they are tangent secant. So I shall say 3 congruent to 4 tangent secant. 3 congruent to 4. 3 congruent to 4. What is the relation between 2 and 3? Are they vertically opposite angle? But 2 and 3 are equal. If you want, you can write down 4 over here. If you want, you can write down 4 over here so that you can understand 4 congruent to 3. But 2 and 3 are equal. If 2 and 3 are equal, 1 and 4 are equal. Check what type of angles 1 and 4 forms. Do they form Z shape, alternate angles? 1, 4, are they forming this kind of Z shape angles? By alternate angle test, the lines are parallel. We are done with the sum. By alternate angles test, the lines are parallel. I hope you have got it. Skeletally, you can say, but I want you to understand 2 congruent to 3. Therefore, 1 equals to 4. Sum is done. Keep this solution in front of you. Keep the skeletal solution in front of you for we to write down the main answer. So our proof starts now. What is our proof trying to say? We shall be saying on the same lines. For larger circle, angle PQA congruent to angle PAM. That's what I'm doing. Equation number 1, following the skeletal solution. By tangent secant theorem for smaller circle. Whatever I did for larger circle, for smaller circle. What is it? Angle what? Angle 4. Who is angle 4? AXY congruent to YAN. Equation number 2. Again, I shall say by tangent secant theorem. Also, which angles are vertically opposite angle? PAM congruent to YAN. Equation 3. Vertically opposite angles. Therefore, from 1, 2 and 3, can I say angle PQA congruent to angle AXY? Children, we have to be very careful now. So I'll write down this step, important. I'll write down with a different marker so that you understand it, remember it. We have stated PQA, AXY, nothing wrong with that. But we don't have to stop at PQA. We have to extend beyond PQX. That is PQX. Why? Because when we say alternate angles, we are going to take the entire Z shape congruent to. Instead of saying AXY, I shall say QXY. Equation number 4. Collinearity Q dash A dash X. I hope my children are understanding this. We cannot restrict ourselves to PQA. We have to go beyond and say PQX and QXY. Now, but angle PQX and angle QXY forms alternate angles for which lines? Line PQ and XY with what is a transversal? With QX as transversal. Therefore, who parallel to whom? PQ parallel to XY. What is the reason? By alternate angle test. By alternate angle test. Sum was quite simple. We just had to understand. We are understanding skeletally 1 congruent to 2, tangent secant theorem, 3 congruent to 4, tangent secant theorem, 2 congruent to 3, therefore 1 with 4. Right?